Hello everyone, I'd like to welcome you to this video titled Modeling and Writing Expressions, and I would like for you to get out your math journal pencil and also your Go Math book and turn to page 261. Now the goal of this video is for you to figure out how you can model and write algebraic expressions. So the first thing I want you to do is look at page 261, and you can see that on my screen, it's the same thing that you're seeing on page 261. So I did take this information out of the Go Math book. So a couple of key definitions that you'll need to understand as we get into Module 10. So first of all, what is an algebraic expression? So think about an algebraic expression is an expression that contains one or more variables and may also contain operation symbols such as multiplication or subtraction. Okay, so it's not just limited to multiplication or subtraction. So it needs to contain, again, one or more variables, and also can contain operation symbols such as addition or subtraction. Also multiplication and division as well. So we think about that definition, and maybe one of the words that may not make too much sense to you is a variable. Okay, so what a variable is, it's a letter or symbol used to represent an unknown or unspecified number. So the value of a variable also may change. Okay, so again, it is used an unknown or unspecified number, so it's a letter or symbol that represents that. So we have a variable, and also there's something called a constant. Constant is a specific number whose value does not change. Okay, you can see a variable, the value may change. Constant, it does not change. Think about it's constantly the same number or the same value. Okay, for example, 150, that is not going to change. The number 150 equals 150 no matter if it's sunny, if it's snowy, if it's a Tuesday, if it's a Wednesday, it's 150. Okay, so think about this algebraic expression. So again, it has one or more variables, has our variable, has our operation symbol as well there. Okay, so think about algebraic expressions, something else that I want you to see, and we also saw this in Module 9 as well, that multiplication and division are usually written without the symbols of x and the division sign, or the multiplication sign and the division sign. So 3 times n, okay, it can also be written as 3n. So whenever there's a constant next to a variable without any symbol at all, it is always understood to be multiplication. So that is really important to understand. Okay, so 3n means 3 times n. 56x means 56 times x. Okay, you can also see the dot here. We talked about that in Module 9 as well. All right, and then 3 divided by n can also be shown as 3 over n in fraction form. And we did see that in Module 9 as well, so it should not be anything new to you. But 3 divided by n will look like this, 3 over n in fraction form. Okay, now you may think about, well, how do I know which number's on the top, which number's on the bottom? So we can see here, dividend on the top, divisor is on the bottom, whenever you're writing it in fraction form there. So a couple things to understand when we're talking about writing expressions. So there are several different ways to describe expressions with words. So addition, couple things that you need to understand. Added to, plus, sum, more than. Whenever you see those words, that means it's going to be an addition type expression. Subtraction, subtracted from, minus, difference, less than. So the answer for an addition problem is the sum. Answer for a subtraction problem is the difference. Understanding that will help you as you write algebraic expressions. Multiplication, we have times, multiplied by. Product, that's the answer of a multiplication problem. And also groups of. And finally, division, divided by, divided into. Pretty obvious there that they're division problems. And also quotient, that's the answer to a division problem. So understanding these different ways to describe expressions with words will help you as you're starting to write expressions as well. So let's take a look at some of these problems here, and we're going to see them in word form, and then we're going to write them as an algebraic expression. And you can see these problems right on page 262 in your Go Math book. So we see n times 7th, so think of that word times and go back to that list on 261. Times means multiplication, and so we have 7n. Again, whenever a constant is next to a variable without any operation symbol, that means it is multiplication. So the next one, we have 4 minus y, okay? And so we know minus means subtraction, and we can just write this right in order that it comes here, 4 minus y. You cannot write y minus 4, okay, because that's not what it's saying. It is 4 minus y, and we'll take a look at how the subtractions ones can be maybe a little tricky here in the next couple of problems. So the next one, quotient of x and 12. Okay, so thinking to that list, page 261, we look at quotient. That's the answer division problem. So that signifies that this is going to be a division problem. All right, so we have x over 12 there. If it was the quotient of 12 and x, then we would write 12 as our dividend, but that's not what it's saying. It's x and 12. So that's how you know which one would go on the top as the numerator here in fraction form and the bottom here or denominator there. So whichever one comes first is at the top. One that comes second would be on the bottom. So now these ones can be a little tricky here. It says k less than 24. So we're so used to taking a look at these word problems or the word form and just writing them out how they come, but you need to understand what they're saying. K less than 24. So that means we're taking k from 24. So what we do here, 24 minus k, and that represents k less than 24. So if there's one that you're going to get tripped up on, it's probably going to be one like that, whenever the first number really should be the second number here with the subtraction problem. Okay, but just understand, think about what you're doing. For the top, when we come up here, we did 4 minus y. Okay, so we have 4, and then we take y away from 4. This one, k less than 24, you're taking k away from 24. Okay, so just something to think about there. Now what we're going to do is we're going to take a look at the algebraic expression, and we're going to write a phrase for each expression. All right, so with these, you do not want to make them too difficult. You got to think about what's happening here. So for this one, we have m, so the m is the variable, adding 83 to that, so m plus 83. So again, you don't want to make this too difficult on yourself. And we have 83 added to m, or you can even do m plus 83. That would be completely fine. So any of those would work with that. Okay, so the next one, 42s. Now, you may look at this and say, well, there's not an operation symbol or anything like that. However, understand whenever there's a constant next to a variable, that means it is multiplication. Okay, so what we have here is we have 42 times s. Pretty simple, right? Not too difficult. So 42 times s, the phrase that represents that algebraic expression. So let's take a look at the next one. We have 9. Even if you think about how you would write this out, 9 over d, okay, or 9 divided by d. And that's how you would write it in the phrase form. Okay, so do not make this part any more difficult than what it is. 9 divided by d is what that represents, and that's how you'll write it out. Okay, so 11x, let's take a look at this. Another way you might be able to write this out, the way that you could write it out, is the product of 11 and x. If you want to get really fancy here, you say the product of 11 and x, and the reason for that product means multiplication. That means when you take 11 and x, multiply them together, you'll get that product there. Okay, so this is how you write the algebraic expressions and also the phrases for the expressions as well in this first few slides here. Now what we're going to do is we're going to take a look at real world problems and representing them with an algebraic expression. Okay, so these problems are right on page 267 in your book. So what we have here, it says the student council is asking people to donate money for the new park outside the school. Everyone who makes a suggested donation amount will be given a bracelet. If everyone donates a suggested amount and B bracelets are given away, so B is going to be our variable, what algebraic expression represents the total amount collected in donations? So what you need to do, you need to think about this situation, okay? And whenever you're trying to figure out a certain amount that was sold and trying to figure out, and you know the price already, what would you do in order to find how much money was collected? So we don't know how many bracelets are being sold here. So B is going to represent the bracelets. Okay. Now we have B there, and we know that each bracelet is $2. Now we're not trying to figure out the final amount that they collected. We're just trying to figure out the algebraic expression that would represent this. So since each bracelet is $2, the algebraic expression that can represent the situation is 2b. Now why is it 2b? Where am I getting my 2 from? That's the amount that each bracelet, the suggested donation. B, that's how many are given away. All right, so we don't know how many are given away. Just remember, a variable, we don't know the amount of that variable. And thinking about the definition of a variable, it's a letter or symbol used to represent an unknown or unspecified number. So we don't know the amount, so that's why we use a variable there. So if you were to take 2 suggested donation multiplied by how many were given away, that would be the algebraic expression that represents this real world situation there. Let's take a look at the next problem. It says Mr. Delgado has some young orange trees. He wants to plant them in 46 rows. If T is the number of orange trees, so we don't know how many he has. It just says he has some. Okay, what does some mean? Some could mean 5 to some people. Some can mean, if you're a farmer, could mean 1,000. We have no idea. Okay, so because we don't have any idea, that means we're using the variable. So he says he has some young orange trees. He wants to plant them in 46 rows. So 46 is what we know. Okay, so that's going to be our constant. T is going to be our variable. Okay, T is a total number of orange trees. Now, if you're doing this problem, it's not like if you put O for the variable that you're going to be wrong. T is just what we're using here, so everybody can be on the same page. It says write an algebraic expression to represent how many trees he can plant in each row. So think about whenever you're trying to figure out a problem like this and you have all the numbers, you have a certain amount of trees, you have a certain amount of rows you're planting, how many are going to be in each row? That's going to be a division problem. Okay, so think about how you solve these problems if you have both numbers, and you'll do the same thing even though you have a variable. All right, so what we do here is we're going to do T for the trees divided by 46. And again, we're not trying to solve this problem at all. This is just the algebraic expression that represents this problem. We can't solve it. We don't know how many are in each row because we don't know what sum means. So we use T to represent sum. All right, let's take a look at the final one. And as I'm doing this, I do want you to write these answers in your book for 267 so you can reference them as well. So the final one says there are 15 violinists in the orchestra this year. Next year, 2 violinists will leave and some new violinists will join the orchestra. So we know that leaving usually means subtraction, joining usually means addition, okay? If V is the number of violinists who will join the orchestra, write an expression to represent the number of violinists in the orchestra next year. So what we have here is we have couple different ways that we could write this. Okay, so we know that we actually have two constants for this, and we know some new violinists will join the orchestra, so V is going to represent that idea there. Okay, so we have 15 violinists in the orchestra. 2 are going to leave, so leaving, subtraction. And then some will join the orchestra, so we can do 15 minus 2 plus V. That would be a way to represent that. Or what we could do, if we just want to have one constant and one variable, we know we have 15 that 2 have left, so the number that's not in here, but we can figure out, not too difficult, 15 minus 2 is going to be 13. Okay, and then we still have new people joining, which is V, so it's going to be 13 plus V. It would be another way to write it out. So either of those would work, okay, for that problem. So this concludes the video on modeling and writing expressions. If you have any questions about this concept, please come and see me.